Alright, so today we're doing 3.4 building quadratic models. So we're looking at word problems and solving based on a quadratic formula. So our first example is the marketing department of Lululemon has found that when certain yoga clothing are sold at a price of $P per unit, the number of X of yoga clothes sold is given by the demand equation X equals 1500 minus 30p. So find a model that expresses the revenue R as a function of the price P. So revenue equals the cost of the yoga clothes times the price. So R equals X times P. And we know that X equals 1500 minus 30p. So I'm going to plug that in. Times P. So R equals negative 30p squared plus 1500p. What is the domain? It's a quadratic function. So we though want to know that only when our y is greater than 0 and when our x is greater than 0. So we know the domain would be x is greater than or equal to 0, and we would want the equation, the 1500 minus 30p, because that's what x equals, greater than or equal to 0. So 1500 is greater than or equal to 30p. So p is less than or equal to 500. So to write this as a domain, it would be from 0 to 500. What unit price should be used to maximize the revenue? So for maximizing the revenue, the maximum on a graph of a quadratic would be the vertex. So we're going to find our vertex. B would be 1500, but it's negative, so negative 1500 over 2 times A, which is negative 30, which equals $25. If this price is charged, what is the maximum revenue? So here we just plug 25 in for P. So negative 30, 25 squared plus 1500 times 25. Plug that in your calculator and you would get 18,750. How many units are sold at this price? So to find how many units are sold, we're going to plug into our demand equation, the x equals 1500 minus 30p. So 1500 minus 30 times 25. Plug that into the calculator and we get 750. So 750 units would be sold. To graph this, we already have some information for us. So we know the domain, and we know that it has the vertex of 25 and then 18,750. So about 10, 20, 30, 40, 50, 60. So 10, 20, 30, 40, 50, 60. And then on the other side, I'm going to go up by 10,000. So 25, 18, 750 is about here. And then if we plug in some other points, we would get our graph looking something like this. And you can graph this on your calculator to get more accurate points. Then G, what price should Lululemon charge to collect at least $12,000 in revenue? So we want to collect $12,000. So that's what our equation is going to be set equal to. I can make this like the ax squared plus bx plus c form. And then I can factor out a 30 on the left side. And then factor what's inside my parentheses. Set the two set of parentheses equal to 0. So P equals 40 and 10. All right, next example. Joe Exotic is building a new tiger sanctuary because he lost the last one. He has only 1,600 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? So we did something like this last chapter, but we'll do it again. So we're talking about area. So we have A equals X times W. And we know that the perimeter, so the amount of fencing is 1,600. And so to find perimeter, you get 2x plus 2w equals 1,600. I'm going to solve for w. So 2w equals 1,600 minus 2x. Divide both sides by 2. And plug that in for w in our area equation. So A equals 800x minus x squared. And then here, what are the dimensions of the rectangle that encloses the most area? And so again, the most would be finding the vertex. So negative 800 over 2 times A, which equals 400. And if you plug that into our perimeter formula, you would get that the width is also 400. So therefore, 400 yards by 400 yards encloses the most area. Next, a projectile is fired from a cliff 500 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 400 feet per second. In physics, it is established that the height h of the projectile above the water can be modeled by this equation given. From where x is the horizontal distance of the projectile from the base to the cliff, find the maximum height of the projectile. So maximum height, again, we're going to go find that vertex. But first, I'm going to simplify the equation that we have. We can simplify that a bit to be negative 1 over 5,000 x squared plus x plus 15 plus 500, not 15, plus 500 equals h of x. Now we are going to find the vertex. So negative 500, negative b, negative 1 over 2 times a, and a is now negative 1 over 5,000. If we start simplifying, we would get 5,000 over 2, which equals 2,500. Then that's at the seconds is at 2,500, so we have to find the height. So we're going to plug 2,500 into our equation. And once that you plug this in to your calculator, you would get that the height at 2,500 seconds is 1,750 feet. How far from the base of the cliff will the projectile strike the water? So if we look at our graph here, when we strike the water, that's at that x-intercept. So to find our x-intercept, we set the equation equal to 0. And then we are going to use our quadratic formula to solve. I'm going to start with finding the discriminant to see how many solutions we're going to have. Or we can just solve. Okay, so -1 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Again, plug into your calculator, and we would get x equals -458 and 5,458. We're going to disregard the negative because we're only looking at this part of the graph, the positive part, positive x. So we're going to discard. So therefore, we strike the ground at 5,458 seconds. Our last equation is the Golden Gate Bridge, a suspension bridge, spans the entrance to San Francisco Bay. Its 746-foot tall towers are 4,200 feet apart. The bridge is suspended from 2 huge cables more than 3 feet in diameter. The 90-foot wide roadway is 220 feet above the water. The cables are parabolic in shape and touch the road surface at the center of the bridge. Find the height of the cable above the road at a distance of 1,000 feet from the center. So based on the facts, we can find a y equals ax squared. So y equals ax squared. And so y is our 526. We don't know a. Oh, and that's supposed to say equals. But we also know x is the 2,100 squared. So a equals 526 over 2,100 squared. We're using this point here because that's the height of the cable above the road, is that point. Then the equation of the parabola, knowing what a is y equals 526 over 21,000 squared. And since it's a parabola, we have x squared. And now we're looking the height of the cable when x equals 1,000. So find the height of the cable above the road at a distance of 1,000 feet. So x represents our feet, so I'm going to plug in 1,000 for x. So y equals 526 over 2,100 squared times 1,000 squared. Plug this in your calculator and you should get y is about 119.3 feet. So at 1,000 feet from the center, we are about 119.3 feet high.